ahead and take out your books, and you'll want some extra paper so you can take notes and follow along with me today. But before we get to that, we have a few questions. And what do we call it when I have 3x squared where x is equal to 4? What would we do with this, Hannah? Yes, please stand. Thank you.
You plug it in.
Right. We would plug it in. And what do we call that process? Do you remember?
I don't remember.
Do you remember Aloha?
No.
It's okay. We call that evaluating. So that's what we call evaluating. And we're going to be doing some of that today. We did it a lot with some of our word problems. We would set something equal to our unknown, and then when we set up our formula, when we set up our equation, we were able just to plug that unknown value in. Because right here, everybody looking up, we don't know what x is, but we do know what it is right here, and that's why we could put 4 in for x, and how we solve this problem. So Aloha, if I put 4 in for x, what would be my first thing to do?
You would do the exponents first.
I would do the exponents first, and why would I do the exponents first?
Because that's first on the list that we were supposed to memorize.
That's right. It is first on the list we're supposed to memorize, known as our order of operations. So what is our exponents? What is 4 squared, Emma?
16.
Please stand when you give an answer.
16.
16. That's right. So we would have 3 times 16. And Hannah, please tell us what 3 times 16 is.
48.
48. Does everybody agree with that? I saw some hands going up. I agree also. It is 48. Now, we've been talking about our word problems and how to work with those when they give us information. And they give us a lot of information that we need, but they don't really give us anything to help us get the answer. They give us lots of sentences with different phrases and numbers. And there's a few things that we want to do when we have those word problems. And one of the first things we want to do is to identify. So when we have a word problem, what are we trying to identify, Hannah?
Any numbers?
Any numbers. We are looking for numbers in our word problems. Aloha, along with numbers, what else are we trying to do in our algebraic word problems? What is it that we're trying to identify? We also identify these in our equations. I'm sorry about that.
We're trying to find the unknown.
Right, we are trying to find the unknown. So whenever we have that paragraph and it's telling us to look for something, we want to label our unknown as something. Hannah, you may spit your gum out and see me after class. So how do we represent our unknown, Emma?
With a variable.
With a variable. What kind of variable? What is a variable?
An x.
An x. Does it have to be just an x?
No, it can be like a y. Something.
Y. It could be E for Emma.
Yeah.
Right, so we want to represent our unknown with a variable. And we're going to be using that more today. And we're not doing exactly word problems, but we're doing something like that. Up to this point, we have been solving word problems. We've been using equations. Remember, we had those questions that said Hannah is 4 years younger than her brother, and the sum of their ages is 30. Now, I just made that up off of the top of my head. But we learned how we can take all that information and put it together. But up until this point, we haven't really been able to see what we were doing, to visibly put it on paper or to be able to see it. But today we're going to be looking at a few things that will help us be able to visualize what it is we're trying to learn. How many of you do a little bit better when you can actually see something? You raise your hand. I see a few of you. I always like it when I can see something. Maybe when I'm studying for science or when I was in school and I was studying in history. If I could actually see it, then that helps me remember it much better and how to solve it. And we're going to be doing that today. Go ahead and open your books and turn to page 148. And we're going to be looking at some different things, but we have 3 words that we want to keep in mind today. And my PowerPoint went out on me, so we're just going to put them up on the board. And our first word is rule. Everybody say rule with me.
Rule.
When you think of a rule, what do you think of, Hannah?
Laws.
She thinks of laws. Okay, that's a pretty good answer. A rule, do rules typically change, Aloha?
They can.
They can, but
But
usually
no.
not. We have our rule in school that we don't chew gum in class. And that is a rule that's not going to change. It's always been that way ever since we were little, and it's going to stay that way until you graduate and probably for years and years to come. Well, that's what our rule is. And you're probably thinking, okay, but what about this rule? What is a rule? Let's say that we go down to the supermarket or the farmer's market. I love going to the farmer's market. Emma, what's your favorite fruit?
Raspberries.
You like raspberries? Okay, so we're going to take raspberries, and everybody in the class today likes raspberries. Just play along, even if you don't like raspberries. I'm not a big raspberries fan, but we're going to be using raspberries today. So let's say that we go down to the market and we have raspberries. Now, we know they're not going to sell it by one raspberry. Normally, you're going to get a bundle or a quart or whatever it is. So we're just going to say one serving of our raspberries. So we have raspberries, and I'm just going to write that down. So we have raspberries, and we know that raspberries at the farmer's market on this week, they cost $2 per quart or bushel, whatever you want to have in your mind, $2 for each thing of raspberries. So if those cost $2, and let's say Emma is going to make raspberry cobbler, and she needs to buy lots of raspberries. So she's going to buy 12 raspberries. Or maybe Hannah just wants some raspberries that she can just snack on later at home when she gets done from school. Maybe she's just going to buy one thing of raspberries. And maybe Aloha wants to share with her brothers and sisters, so she's going to buy 3 things of raspberries. Well, we know that the raspberries are always going to cost $2 per how many we buy. So are they going to charge you $2 for your raspberries just like they charged Emma, Hannah? They're not? What do you think, Aloha? I think they are. If we go to the store and I buy raspberries, well, the person behind me in line is going to pay the exact same price. So it's the same price per one raspberries that you're buying. So we can say that we know the cost. Now, the cost might be different altogether for you, Hannah, than it is for Emma, but we know the cost is equal to $2 times the numbers of raspberries. And I just want to abbreviate it with R. Does everybody follow why I used R for raspberries? Any questions up to this point? So now we could look at it and say that Aloha wanted to buy 3 things of raspberries, and we know that they're $2 and we have 3, so we could just plug in 2 times 3, and we can see that Aloha is going to have to spend $6 on her raspberries. But even though Aloha is going to spend $6, we know that she paid the same price. She paid the same $2 per thing of raspberries. So Hannah, if you wanted to buy 4 things of raspberries, how much money would you end up spending?
$8.
You would spend $8, and she did that by doing 2 times 4. That's great. So our rule is that every set of raspberries, every peck, bushel, is going to be $2. So we can say for every raspberries, I know that sounds kind of weird, but Emma picked a fruit that has a bunch of little ones, and that's okay. For every raspberries, it's going to be for every raspberries, it is $2. So we can have it like that, but you see how here we just had cost equals $2 per raspberries? That's a lot more simple than having to say every single time. For every set of raspberries I want to buy, it's $2 per set of raspberries. That gets really wordy. That gets a lot, and we can just abbreviate it. And we can abbreviate this even more by saying our cost is equal to 2 off. So this is our rule, because that's not changing, right? It's going to be $2 the whole time. But this is our formula, because that might change. What's going to make it change, Aloha?
If the cost of the raspberries move, that gets more expensive.
So if the 2 changes,
Yeah.
but that's our remember,
Yes.
in our equation. So what's going to make it change?
The
They're raspberries. And what does that R represent, Aloha?
The amount of raspberries.
Right, and so when we have an equation, what do we call that
The
R?
variable.
The variable, that's right. So we can see how even in this we have constants and we have variables, just like we've been working on this whole time. So this is our rule, and this is our formula. So we have a rule, we have a formula, and then we have one other thing that this is where it actually helps us visualize and see how many we have, see how much we're spending. We can see it all together in one place. And I like it when I can see everything all together and it's not all scattered. So I already erased on accident, and I'm going to go ahead and put C equals 2R. And we remembered that because we know the cost is equal to $2 times however many raspberries we choose to buy. Well, what if we set up a table? And no, I'm not talking about a table like this desk. I'm talking about a table where we can put everything together. And your book, if you want to look on page 148, your book kind of sets up tables like this. So I'm going to have just a long line, and then I'm going to have a little T. So this is my T right here. And we're going to have something on the top line, and then we're going to have something on the bottom line. So I'm going to put right here, this is my R. What do my R stand for, Hannah?
Raspberry.
Right, however many raspberries we have, right? And then this bottom part of our table is going to be for the C. And what does the C stand for, Emma?
Cost.
It stands for our cost. So we're just going to fill out this table as we go through. Aloha, how many raspberries do you want to buy?
I would like 7.
She wants to buy 7. Emma, how many do you want to buy?
I want 8.
You want 8. Okay, we're going in order here. And then Hannah, how many would you like to buy?
4.
You want to buy 4. Okay, way to be different. We didn't go. So now we're kind of going in, well, it's not in any kind of numerical order now, but that's okay. We're going to work with it. So we have C and we have R. If we know what R is, what are we looking for, Hannah? What's empty on our chart? Our cost, that's right. She's catching on because remember earlier we saw how many you wanted to buy and we plugged it in to figure out our cost. So now we can just look at our formula and fill in our chart. So I'm going to go ahead and start with this one and say cost equals 2 times 7 because I have 7 and I want to see how much Aloha is going to have to pay. She's going to have to pay $14. Now we're going to see how much Emma's going to have to pay for all those raspberries she wants for that cobbler that she's going to make for her family. Emma's going to have to pay $16. And now Hannah just got some for snacking purposes. So we're going to see how much Hannah has to pay. Hannah is going to have to pay $8. So now everything is right there. So if I went to the store and I wanted to see how much is it going to cost to buy 8 things of raspberries, I can look right here and see it's going to be $16. If I was going to buy 4, I can see it's going to be $8. So we can see how our rules influence our table. If our raspberries cost more, then our table would change. If it costs less, then our table would also change. So that's why it's important that we know our rule, and then we write our formula, and then we use our formula to plug it in to our table. Go ahead and look at number 1 on our practice problems on page 148. Aloha, please stand and read that for us.
Apples sell for $1.80 per pound. What is the cost of pounds?
Okay, so they already gave us our variable. She said apples sell for $1.80 per pound. Hannah, make sure you are paying attention. What is the cost of our pounds? So we know that the apples sell for how much, Emma?
$1.80.
$1.80, that's right. So we're going to have, we know that apples are $1.80, or for our paper purposes and doing our work, you could write 1.8 because we know that doesn't change our value any. Our $1.80 times, right? If I say $2 per raspberries, we know it's 2 times however many raspberries. So we can say apples are $1.80 per unit if we wanted to, per bushel, per basket, whatever you have in your mind, per unit. And that is our rule, per unit of pounds. We can't forget that because they told us that's what we're looking for. We're looking for pounds. So that is our rule. So go ahead and read that rule to me, Aloha. Yes, read this. This is our rule.
Apples equal $1.80 per unit of pounds.
That's right. Very good. So we have our rule. Now we have to make a formula for this. So our formula is the one where it's shortened, and we just have our cost, because we want to know what the cost is per pound. So we would just come and put our C, because C equals cost. We're just going to keep it pretty uniform throughout. So C equals cost. Now, what is our constant going to be, Hannah, based on the information that we have?
$1.80.
$1.80, because that's not changing. If Emma buys apples, they're $1.80. If Aloha buys apples, they're $1.80. So our constant is $1.80. So the only thing that's going to change could be our pounds. Maybe we buy a lot of pounds, maybe Emma's buying just a few. So that is where we would just have our P, because that's what could change. So if this is my rule, what is the formula, Emma?
C equals 1.8P.
Right, because we can use that formula to decide, to figure out how much money it's going to cost based on how many pounds. So go ahead and look at number 2 in your books on page 148 in practice problems, and work on that one at your desk. You should write a rule, and you should write a formula. Okay, once you're done, you can go ahead and look up this way. With that, once you have written your rule and your formula, you should have both of those. We're not working on a table just yet. We're just working on our rule and our formula. Okay, everybody's finished up, so go ahead and Hannah, read us number 2. The whole problem, what it's asking for, read it to us.
A book sells for $8.95. How much would X books cost?
Okay, how much would X books cost? So we're looking for the cost of X books. They already gave us the variable that we're going to use. So what did your rule say, Emma? What did you come up with for your rule?
Cost equals 8.95 times the number of books.
Cost equals 8.95 times number of books. Is that right?
Yeah.
So that is our rule. I'm going to label this right here as our rule so we know what it is. How many of you got this? If you agree, nod your head. That's what I had. That's exactly right. So that's our rule. We know this rule is not changing. The bookstore is going to keep this price for each customer. It's not going to be different for me. I'm going to pay the exact same price as everybody else. So if cost equals $8.95 times the number of books. Well, now we need to put that in a formula, something we can actually work with, because I can't really work with this right now. If Aloha wanted to buy 3 books, I can't really do much with this. So what would we do? How did you write your formula, Aloha?
I did C.
So So she had C, and what does your C stand for?
Equals 8.95.
B. Okay, that is a great job. That's exactly what I had. C equals 8.95, and she used B for books. Some of you might have used X for the number of books instead, but we know that it's all the same. So what does the C stand for, Emma?
Cost.
It does. It stands for our cost. Okay, great job. Now we're going to look at our table. So we've learned how to write a rule, we've learned how to write our formula, and the next thing we have to learn is how to construct a table. And we have an example for us. We're going to go ahead and do number 5, and it gives us a rule. You can't make a table without a rule, so remember that. If you don't have a rule and you don't have a formula, then you can't really make your table. You can't fill it in without any information. If I just say, make a table, well, you have no information to go on. So that's why it's important that we follow our steps of having a rule, getting a formula, and then also having a table. So number 5 told us that P is equal to 2y. So is that a rule or a formula, Emma?
A formula.
Make sure you stand.
A formula.
It is a formula, you're right, because it's something that we can easily work with. And they have set up for us that y goes on our top line and that p goes on the bottom line. So I'm just going to extend this through, and we're going to have our lines. And we know each one we're just going to mark off. And it starts at 0, and we're going to go up through 10. So we know that y is our variable. That's what we have however many of, and we're looking for our p. So I'm just going to have 1, 2, 3, 4, 5, 6, make this longer, 7, 8, 9, and 10. We're taking up the whole board. So now we need to figure this out. We need to be able to fill in this bottom part because we know how many y's we have, but we don't know what our p is. We need to figure out the value of that. So what's the best way for us to go about that, Hannah?
You just multiply y.
Right. And y times p, what are we going to multiply y times? Try again.
P times however many y's we have.
Okay, we're going to multiply it. We're going to multiply 2 times however many y's we have. That's why it's important to use our formula. So we're not just using this without anything. We need to make sure that we're using the formula. If they don't give us a formula, then you can't fill in the table. So you have to have your rule or your formula in order to fill in the table. So we know that this is our formula, and we're looking for p. They tell us how many y's we have right here. So on our first one, we can go p equals 2. And what do we have for our first one, Aloha? 1. So what's our answer going to be, Emma? Make sure you're paying
2.
attention. It's going to be 2. And now you can see that we could kind of do this in our head now that we know our formula. So we know that we're going to take 2 times 2, class. 4. What's our next one going to be, Hannah?
6.
It's going to be 6. Aloha, what's that next one? 8. So you kind of see now we have a rhythm going for our table. Emma was ready to go. Go ahead and tell us what the next one is. 10. Our next one, Hannah?
12.
12. Class, if we have 7.
14.
Emma, if we have 8.
16.
16. Aloha, if we have 9. 18. And Miss Jordan, if we have 10, we have 20. I wanted to have a turn too. So now you can see how we fill out our chart based on our formula. Would we have been able to fill out the chart without a formula, Emma?
No.
No, why not?
Because we wouldn't know what numbers.
Right, we wouldn't know what the value is per y. That's a great answer. Go ahead and look at number 6. And number 6 gives us a fraction to work with. Go ahead and fill in the table for number 6. We're going to do that one just like we did this one. work out to the side, you can. And we'll make sure you're working on the work from our book. Yeah, it's good work, but make sure you're working diligently. That was very good. Aloha. Yes, Emma,
Can I go to the bathroom?
you may. You don't forget your homework. Okay, once you're done, you can look up this way with our chart from number 6. Okay, so you should have used the formula to fill in this chart. And what formula did they give us, Aloha?
For number 6, they gave us A equals 2/3 x.
That's right. So that's what you should have used to fill it in. And really what you're doing is just evaluating. You're just taking, however, the number they give you and plugging it in and figuring out your answer. So we're just going to go through. They gave you 1 and 2, so we're going to pick up with 3. The number 3, what did you get for that box, Hannah?
2.
Very good. Aloha for 4.
2 and 2/3.
Okay, that's great. 5, you should have had 3 and 1/3. 6 would equal 4. 7 would equal 4 and 2/3. 8 would equal 5 and 1/3. 9 would equal 6. 10 would equal 6 and 2/3. 11 would equal 7 and 1/3. 12 would equal 8. And 13 would equal 8 and 2/3. 14 would equal 9 and 1/3. And 15 would equal 10. That was a lot of numbers. Raise your hand if you got them all correct all the way through. Great job. We're really just doing our simple arithmetic as we go down through our tables. But let's look back. Let's look at our table, P equals 2y. So they gave us that table. That was on number 5, and we have all the answers for that one. So we have P equals 2y. Go ahead and direct your attention over here to this board. We looked at a table, but now we're going to look at something that can represent them the same, but it's going to represent a graph. This is a graph that's representing all of our answers just the same. So we want to say that this line right here is going to equal P, and this line is going to equal Y. So we can have numbers on this graph, and you'll have some of these graphs in your book, and we'll need to get some graph paper when we're graphing some of our homework. And we know if I had this as a graph, y'all seen graph paper, we would have little notches going up, and we would also have notches going this way. And each one represents a unit. Ours today are just going to represent each one. Go ahead and get in your mind that each one of these equals 1. So this is 1, 2, 3, 4, 5, 6, 7. And this is going to be 1, 2, 3, 4, 5, all the way through each notch. So how many does each notch represent, Aloha? 1. It does represent 1. So what is my rule over here? What is my formula, Hannah?
P equals 2y.
P equals 2y. So go ahead and look at number 5 because we're putting this on a table, and this is one that you should already have all of your answers for. So we know that if P equals 0, what does our y equal? Looking at your table, Emma.
0.
It also equals 0. So this is 0, and this is 0. We can just put a nice little mark right there. Well, let's go ahead and move on to if P equals 1. If P equals 1, what does our y equal, Hannah?
2.
It equals 2. So I would just come out here and plot my point. This will be a lot easier when you actually have your graph paper for homework, and you can keep it a lot neater, a lot nicer looking. So if we already did that P equaled 1, well, if P equals 2, Aloha, what is our y value going to be?
4.
It's going to be 4 because we can just follow our table. So we had 2, and we're going to come over 4 spots. Now, what if they didn't, we're not quite done with our graph, but don't look at your chart. What if they didn't give us the table? Would we still be able to figure out what each of our values are, Aloha?
Yes.
And how would we find them?
You have to make your own chart.
Right, we have to make our own chart, but we still need something to know where our points are gonna be. And what would we use, Emma?
Our formula.
We would use our formula, that's right. Remember, I said you can't make a table without a formula, and remember, we can't make a graph without our formula. So we've already done what? 0, 1, and 2. Let's look what if 3 was. So if we had P is equal to 2 and we have 3, then we would just put our 3 in, and P is equal to 6. So for each value, we can see that we would just plug it in, and then we could chart it. So we would chart this, and you'll have a straight edge for homework, and you would just draw your line through the points to connect them. Go ahead and look at number 10, and we're going to do number 10. Do that one at your desk, charting it. They've already labeled your graph for you. A is at the top, your X is at the bottom. Go ahead and do number 10. It looks like everyone has almost graphed their line on the graph. So we can't all come up here and draw a graph on the board because that would take too long. But we can see if our points match up, and if Aloha has the same value for her points as Emma does, and I have the same as they do, then we know that they did their answers right. So we're going to go through, and I'm going to tell you what your points should have been. And if you have any questions, just let me know or see me after class, and you can compare your graph to mine to make sure that you had it right. So you should have had 0 and 0. You should have had A equals 2 and X equals 1. The next point should have been A equals 4 and X equals 2. A equals 6, X equals 3. A equals 8, X equals 4. A equals 10, X equals 5. A equals 12, X equals 6. A equals 14, X equals 7. A equals 16, X equals 8. A equals 18, X equals 9. And your last point should have been A equals 20, X equals 10. How many of you, that's how your line went and you had those corresponding points? Okay, I see some hands raised. Great job. You're going to be working tonight with your formulas, with your rules and your tables, making sure that we put them all together and we learn how to write them, and we also learn how to visualize them. Go ahead and take out your homework notebooks. We're going to be doing sharpening skills 2 through 20 even tonight. 2 through 20 even. You are dismissed.